I personally am very committed to the idea of collaboration across academia, activists, policymakers, and of course companies. I think the GDPR is sort of a cathedral. It's a monumental cathedral. It took many years to build. It will be with us for many years. But what it means will depend on what we, the faithful, make of it. It's a text that says a lot of different things, but it is just a framework text. And what it will mean will be what we make of it practically. Eric reminded me of the ancient nature of the University of Vienna. I went to Harvard, which at the time I thought was an old university. It was founded in 1636, but compared to University of Vienna, I realized Harvard was a startup, a somewhat successful startup, but there you are. So I've spent the rest of my life working in startups. Eric mentioned both of them, but when I started, they were both startups, Microsoft and Google. And so my particular experience is how to, as the accidents of life would have it, build a privacy program from nothing to something that scales the needs of a very large corporation. And I've done that now twice. Getting ready for GDPR with less than 1 year to go, I brought together a team at Google of over 600 people. Over 600 people getting ready for GDPR. How a small and medium-sized enterprise is supposed to deal with the GDPR is really quite baffling to me. We have more engineers alone working on GDPR readiness, over 300, than the largest staff of any DPA in Europe. That's just a fact. Of course, we're a large company with big challenges, of course, but it does require a very large group of people across engineering, user interfaces, legal and policy and other areas to do what you need to do. Now I'm going to give you an overview of what Google is doing to get ready for GDPR, but this is not a marketing conversation. You know, when I come here, I want to talk and hear from you as much as you hear from me. Feel free to jump up, throw a question, throw a challenge, not throw a tomato at me as you like. I came to Vienna with also to talk to you, but I started my trip with a rigoletto at the Staatsoper last night, which was wonderful. So I'm going to go back with happy memories, no matter what you say to me here today. The GDPR requires, obviously, transparency, choice, and control. And these are not the words of the GDPR, but I'm going to put it in the terms of what we're doing with it. We are building into the services these core ideas that people have to have choice about how their data is collected and used. Transparency, in other words, to understand it, to see it. Control, to give consent or not, or to what. And of course, security, which has been discussed quite a number of times. These, to me, are the 4 platforms of what we're doing to get ready for GDPR. And how are we doing it? Well, it's not just for GDPR, and this is not just for Europe, however important those 2 things are. You hear from my accent. I'm involved in these matters at a much broader level than just getting ready for GDPR. We are building tools. That's what we do. And the tool that we have built to make these principles real for real users is something that we call My Account. Now, I assume that, or at least I hope, that there are a few of you who are users of Google services in the room. And if you are, you can click on My Account, top right of your screen, if you log into Gmail or anything else. And you too can have instant access to all the data that's associated with your account. Now, from the point of view of a privacy expert like myself, when we started launching these challenges and said, let's build a tool that lets people see, access, and control their own data, we had no idea how many people would use it. You know, you sketch out an idea, you say this might be a good model, let's build this out, let's iterate on it, and let's just see, do people like it? Are they going to use it? And here are the results from last year alone. We had 1.6 billion, with a B, billion unique visitors in 1 year to the privacy controls of My Account. Now that's stunning. I think you would see at many companies privacy controls getting some traffic, but not a lot. 1.6 billion is extraordinary. Remember, there are only 3.5 billion people who have access to the internet on the planet. So the numbers do confirm a few principles to me. One is, if you give people tools that let them control and access their own data. Yeah? Sure, okay, please. It's always nice to have a little tech help. You know? So it does confirm to me that these tools will be used when you make them available to people. Great, thank you. We also work very hard, and I work with a large number of user interface colleagues to design privacy controls in a way that are very simple. The learning is the more simple you make them, the more they will be used. And that is, after all, the goal, which is to give people control over their own settings. This is one example. There are hundreds of others across Google services that I could cite for you. This is the one about location history. Do you wish the service to remember your location history or not? And so look, on the left screen is the German language version. So as you see, we just have a slide just from Standortverlauf an, okay, if that's what you want, or das geht niemandem was an, on the other hand. I don't know if you can make it any simpler than that. And by making it that simple, we are putting users in control of their own choices for this sort of thing. Now on security, I'm not a security expert, I'm a privacy expert, but it is quite obvious that this is the foundation on which all of privacy exists. I don't view them as being in conflict, I view them as just frankly the foundation. If you don't have adequate security, the entire edifice of privacy tumbles right over. This is just our statistic. We have over 600 engineers who are working in the field of privacy, obviously world-class security engineers themselves. And the reality is that we do have a global network. And it's a global network not just of data centers, but of the entire physical infrastructure of the internet. And it does span the globe, and it was designed to do that. And it was designed to correspond with the entire architecture of the internet, which is to route data around the world most efficiently at the fastest way possible. And this is the reality that we all face. It's also a slide that I like to show people to remind them that location-based legislation will fail in a context like this. There's been very few such attempts around the world, but there have been a few. The internet simply routes around it. That's how the world works. And I think we just need to face that reality, even though it does present some challenges to national legislation or regional sovereignty at times. The challenges in this space simply are global, and that's just the reality of it. I won't dwell on this slide other than to say you can't summarize security with one or two phrases. To me, it's a combination of an entire array of tools, services, expertise. It's of course not just security at the server or service provider level, it's of course also the interaction between security at the user level as well, and across all of these different dimensions. As you can see, it's not just our hardware data centers, data network, vulnerability management, security monitoring, user authentication, encryption, internal access controls, and incident management. Hopefully there are very few incidents, but if they happen, you need to have the entire team ready to spring into action immediately. And again, this is the sort of thing that the large players, I think, need to be able to scale out to help the smaller players not become the weakest links to the overall architecture. One of the things that we did from the user point of view, because the user point of view can often be these weak links of security, is pushed out a security checkup to users. And last year, it was an experiment, a security checkup that, as you can see, gives people very basic guidance on their own security settings, such as do they have account recovery information on file with Google? Check the different devices that they use to access the services. Check their account permissions, for example. Have they provided permissions to third parties? Are they using two-step verification or not? So we pushed that out, and we had 227 million users in the course of the year, 50 million who are in the United States, go through the security checkup. I'd like to see those numbers go up, but nonetheless, those are really quite substantial numbers, I think, by anybody's estimation. Now, a word or two on the GDPR accountability framework. This is a way of saying that it's complicated. We have a lot of services. Those are the things in the middle. The little icons will represent different Google services, some of which you hopefully are familiar with. We have over 7 of them that have now over 1 billion active monthly users. But anytime a new service is launched, those things in the middle, it goes through a privacy review. It always has. The difference is the privacy review will now be adapted, or will be shortly, to the requirements under the GDPR for the DPIA impact assessment. So those specific requirements that are taking place there. And all of that, of course, is on a foundation of many other elements. The privacy policy is probably the most foundational element that everyone is familiar with. We've updated that repeatedly to try to make it as simple and readable as it can be. But it's all the other elements that are there. Now, in the past, as you know, and in parallel to privacy reviews, anytime a company like ours launches a new service or an update to an existing service, it goes through many reviews. It goes through a security review, obviously. It will go through reviews, for example, for latency. Questions about, how quickly does an internet page load for a user who will access it in Vienna or in Kuala Lumpur, as the case may be. And it will also be a privacy review. If it fails the privacy review, it will not be launched. That's how it works. And of course, all of these services have to be able to deal with incidents, if there are any, and the ability to take data out of the service to meet the requirements under GDPR of data portability. So with one click, people can find a way to take their data, if they wish, from, say, Gmail to a competing service. Hopefully very few people will find that a compelling proposition, but nonetheless it is clearly a possibility that we have designed and clearly a requirement under GDPR to make that available. We'll see how other companies do. When I look at what's going on here in this space, I'm seeing some large companies invest extremely heavily, as I said Google is, on getting ready for GDPR, but I'm not seeing that across the entire industrial landscape. I'm most certainly not seeing that, and here we are less than a year away. If you're not getting ready for GDPR yet, I don't know how you're supposed to be ready a year from now. This is not something that can be launched, the week before, right? I want to say a few words on Privacy Shield, international data transfers. Well, first of all, as that slide on the global network showed, international transfers, that simply is the reality, and it always has been the reality, and it always will be the reality in this space. So there have to be instruments in place that provide the legal framework to enable them to happen. It is simply not an option to say there is no legal framework for this. So the question is which one? And the one that's been debated quite a bit recently, of course, is the Privacy Shield, negotiated between the European Commission and the US government. I just want to say a word or two about what Google has done on this. Now, there was a lot of criticisms from some people, and even some people in this room, that the predecessor arrangement, the safe harbor, was not robust enough. I won't get into the politics of it. I will certainly say the Privacy Shield is more robust. It's a different debate about whether you think it's robust enough, but it's certainly more robust than the Shield that it replaced. And from the point of view of Google, it certainly involved more work to comply with it than the Shield did. Than the safe harbor did. In our case, the review to prepare for it, it's only been in place for now less than a year. It took 4 months across all of our products and services. We trained every employee for Google worldwide on their obligations under privacy. We did literally have hundreds. These numbers are precise. We had hundreds of people, again, across legal, engineering, and product management who were involved in reviewing every Google service against the requirements of the Privacy Shield. And of course, then we certified, it was back in August, so at the end of the month. As you know, we reviewed again by the DPAs, as they said, first annual review. There will be numerous annual reviews of the Privacy Shield, so we look forward to understanding what that will mean. I think it's important for companies that are certifying under the Privacy Shield to step up and say, here's what we're doing. This is what it has meant for us practically. One thing it has also meant for us practically is, although there have been 90-ish inquiries from users in Europe relating to the Privacy Shield, there has been zero, not one, formal complaint, in the legal sense, formal complaint. So I'm trying to understand to what extent these are frameworks that everybody in the field is living up to. I can just speak to Google and what we're doing. Now on requests, I just want to say a little bit about the request of user access to data, from law enforcement access to data from users. This is, of course, a dimension of privacy. Of course it is. And we all know that law enforcement, for whatever its purposes are, from whatever country we're talking about, will occasionally make requests for user data. And these are the statistics. We publish them in 6-monthly increments that show how many such requests we get worldwide. Now, there of course is a legitimate need for law enforcement to make such requests, but I think it's also important for companies like Google to be as transparent as we can publicly, as we're permitted to be by law, about what's going on. I mean, that sort of transparency, I think, is important to the bigger, broader debate on this topic. So we have a google.com/transparency report place where we publish this information. As you can see, the numbers go up, but they're not going up dramatically. Nonetheless, you could say, is 50,000-ish requests from law enforcement in a 6-month window worldwide a lot or a little? I mean, it's a big number on the one hand. On the other hand, of course, we have billions of users. So it's a percentage, depending on it. But from my point of view, the important thing is that we are transparent with the world about what's going on here. Of course, this is just one slide. We also publish it by country. We also publish by country the number of requests we get and the number of requests that we answered, which is to me an even more interesting statistic. So here are the percentages of requests to which we responded with some user data. As you can see, that's been very stable over time. Our review is, does the request meet the standards of law? Right? Is it living up to the requirements as defined under domestic law to provide data? When I say some data, the data that would be provided would vary depending on the kind of request and the legal basis of the request. So it may be as little as, here is the account information, username, date created, and so on, which would be very simple and does not require the highest level of legal authorization. Or it could be a deep request, which goes to actual data, for example, someone's Gmail communications, which is a much higher standard. And of course, internationally, it becomes more complicated because we have to follow international proceedings for this, such as the mutual legal assistance treaties that exist amongst countries. But as you know, the MLAT, Mutual Legal Assistance Treaties framework, are old. They were developed over a century for a pre-internet world, and they don't adapt particularly well or quickly to the new realities. So we all need to collectively come up with something that works better than that. And now I want to just change gears a bit and talk about the reason I get out of bed in the morning. And trust me, it's not to fill out GDPR forms, as important as that may be. So just don't anyone write a headline, Peter Fleischer made fun of GDPR forms. But for machine learning is the new wave of everything that matters in the new world of tech. This is not a new trend, but it's a sort of trend that is exploding into consciousness now. Amongst my engineering friends, one of the phrases that they like to use about machine learning and AI is the Cambrian Revolution. So that's a reference back to evolution. As you know, life forms have been evolving on the planet for, something like 4 billion years. And there was simply a small little moment in evolutionary history called the Cambrian period, where suddenly, boom, just the diversity of life on the planet exploded in a way that was non-linear from what had preceded or what came afterwards. There are moments in time when the elements that had been put in place over many years or millions of years in evolution, suddenly it's all in place and boom, change happens very quickly. Well, my engineers say we're in the Cambrian Revolution period of machine learning. And this is, for people who like to think of it in sort of marketing terms, this is the hockey stick moment, where things kind of go like this and then boom, they just like take off. Well, that's why I'm so excited about this era. I'll give you a few examples. It's not just the future. We already have this in place behind some of the very large-scale things that you are familiar with and that people already work in. The reason computers are now getting so good at doing language translation, understanding human language, the ability to do real-time translation, the reason that that is improving so quickly is all driven by machine learning. Why is that? You know historically, human language, just to take that one example, was extraordinarily difficult for computers. Computers were very binary. A human being would program a computer to say, if you see X, then Y. Well, that's a terrible way to do human translation, human language translation, because of the ambiguity, because of the context dependency, because of the nuance, because of all of those things. That's why computers were so pathetic at dealing with language, and that's why they're so bad at dealing with translations. But we're now in a world where the machines don't need to be programmed by a human being. A human being no longer has to say, if you see this word, Datenschutz, translated as that word, data protection. Machines learn the context of language the same way a human brain learns the context of languages. So we now do real-time translations in over 100 language pairs. And if you think of that mathematically, 100 language pairs, so 100 times 100, is now we're talking about 10,000 languages, which is kind of an extraordinary thing. And it's just the power of machines. There will be a future that we are now embarking on already where we no longer type into our stupid machines, and people of my generation still have problems typing in with my fingers into these devices. So I'm quite looking forward to the point where we simply talk to our computers, as we should. I mean, Star Wars, everybody was talking to their computer. You remember? That was obviously where we as humans go. We communicate with language in our voices, so that's where we should be going as Google. And that's the sort of stuff we're doing. Image recognition was also another area that computers just couldn't be programmed to recognize an image by humans. But machine learning enables computers to recognize imagery in a way that would never have been possible. These are just real-time examples. You'll see this already at very large scale in Google Photos. You'll see that in lots of other ways. I mean, the point has gotten now so good that the computers have taught themselves not just to recognize a dog in a photo, to use that example. The computers can now recognize the breed of the dog, which is kind of extraordinary. If you think about it, the computer doesn't know it's a dog and certainly doesn't know that it's a Dalmatian. A computer is just seeing forms, right, shapes. And it just puts together mathematically that these shapes correspond to that thing. Well, let's say a word about how that all works. And this is sort of my geekiest computer engineering type slide, but I think it's important for us to think about this from a privacy point of view as well. This deep learning technology that we're using is what we call the deep neural network technology. So deep neural network simply means that it's following a complicated path. Am I interfering with that? Okay, yeah. So was somebody like instant messaging me saying bullshit, or do I say no? Okay. I sometimes look at my devices. If this was a Google meeting, that's what I would be getting. You know, so if the neural networks is a pattern of where machines get from input A to output B by going through a number of different layers, just as our human brain. We call it a neural network because, of course, that's how our human brain works as well. And just like a human brain and our own neural networks inside our head, we don't know the exact path that it follows to get from point A to point B. And if you do the exact same experiment 5 minutes later, it will not follow the same path to get from A to B in our brains or in these machine networks. In privacy terms, I think the two pieces to focus on, and these are the ones that I focus on as I think about many, many, many new experiments in the field of machine learning. We have over 1,000 going on right now. You look at the input layer, so that's at the bottom. That's the data that the system is either being trained on or that it is analyzing. And the output layer is the answer, the result. It's sort of, here, the example is we're simply trying to identify whether that creature in the laundry basket is a dog or a cat. That's the query. The input layer, of course, is it's not just this photo, but it's the collective learning of the system of all of the tens, hundreds, millions, many millions of photos that have been labeled as dog or labeled as cat to train the system to learn to recognize that particular object. And the output layer is what it decides. The system will either say, this is a dog or this is a cat. Now, if it gets the answer wrong, humans can go back and provide reinforcement learning, just as we would with children, right? And say, you layered that as a cat. Actually, it's a dog. Machine, go back and try to understand why you came up with the wrong answer, called reinforcement learning. But if you look at the input layer, you can see that you can train a machine learning technology with any amount of data, large or small. People sometimes think machine learning is synonymous with big data, and it's not. I mean, big data can be used to train machine learning systems. So for example, if you are going to train a system to do translation from German to English, frankly, the larger your data training modules are, the better your translation systems will learn to be. But it doesn't have to be. You can have very small sets if you want to. And similarly, from a privacy point of view, the input layer may implicate privacy or it may not. You can train a system to understand human language that is spoken, or you can train a system to understand Wojciech's language when he's speaking to this audience in a very particular way. We can have a system that is designed with a Google Assistant that can understand any human being speaking at the device, or we can have a system, and we do, that will recognize a particular person's voice and only respond to that person. Or, and this is where it gets even more interesting, this is what we're doing, I can walk into my device and I can say, good morning device, okay Google, hey Google, whatever, and say, hi, good morning Peter. It will recognize me. And it'll give me my emails that have come in. It'll give me my search preferences. And then my partner could walk into the room and it'll say, good morning, Chris. And I'll say, hi. We'll recognize the difference between our voices just by saying, hi, Google, and give him his results. And then another person could walk into the room and say, hey, Google, and the system doesn't recognize that person's voice, no voice authentication of the person, can still give them results, but it won't be authenticated to an account. Can answer a question like, hey, what's the weather going to be like in Vienna today? But if that person says, hey, show me Peter's emails, they won't get them. So that's kind of extraordinary stuff if you think about it from a computer science point of view. I'm extremely excited about that. The other area, and just to say a few words, I'm coming to the end shortly, is in the field of health. Machine learning is obviously going to be the source of massive improvements in the healthcare arena in the years ahead. And we're already working on the sorts of things that are the most suitable to this kind of machine learning technology today, but the numbers of fields will expand dramatically. Anything relating to scans, my example here is diabetic retinopathy, so it's a scan of the retina that can distinguish healthy from diseased retinas that are related to diabetic deterioration of the retina, actually a very common form of growing blindness amongst older and diabetic people. And the machines are better than humans at spotting one. How did we get there? We did a deal with the NHS in the UK to share lots of scans that had been marked by doctors as saying this scan of this retina is healthy, this scan of this retina is diseased. And by training the systems with the input layers of disease versus healthy scans, the machine taught itself how to recognize the characteristics to distinguish between healthy and diseased scans. That's fascinating. Nobody said, no machine, no programmer said, if you find this thing, this spot, then that's probably, it taught itself. And that's just stunning. So if you think about machines teaching themselves to distinguish elements of health from elements of disease, in this context, you can apply it to many, many, many others. This does not replace the doctor, obviously. This is the kind of thing that supplements what a physician can do and turn to. Remember, the machine can have seen quite literally millions of scans and understand and learn the difference based on a data set of millions. The best physician in the world may have seen a few thousand diseased retinal scans in a professional lifetime. And so this is not competition. To me, this is obviously way of machine learning supplementing all of this. And this is one example, but I use this example because I think it's incredibly simple to understand. Intuitively, we get this. But I see machine learning, especially in combination with robotics, as doing massive things in the field of health in the years ahead. And the GDPR is the framework that has to survive in parallel to the real developments of technology, such as this, in the years ahead. We're doing this at very large scale. It can be done at very small scale, but for us already, if you're a Gmail user, 99.9% of spam and phishing is identified by machine learning. So what do I mean? No human being has labeled a particular email as being spam. Now, you can label it as spam and train the system, but now at 99.9%, we're no longer dependent on human labeling of spam by either the user or the system. The machine itself is so good at identifying the characteristics of spam that it reaches these levels. And of course, we are talking, as you quite obviously know, about billions per day. So this is a very large system. And of course, you could do the same thing to filter out violent or porn results with less precision than today than spam, but you could do this. Now remember, I'm as somebody who thinks about these issues not just from their utility point of view, but also, of course, from how they can be misapplied, and we're quite cognizant of the fact that in the hands of a bad actor, these same technologies can be used in bad ways. I mean, if you are a government who is determined to censor content on the internet, the same machine learning driven technologies that allow us to filter out spam and phishing could be used to filter out the kind of speech that they do not wish to see take place in their country. But this area may be one of the answers that we collectively have to the field of fake news and the challenges that that's presenting, frankly, to our societies and our democracies. I'm using big words, but I think it is, those big words are important. So I would say Dankeschön, thank you for the attention. I'll be here all day.
Thank you very much, Peter. Fascinating speech. Very remarkable. Only a few words from my side. You're still collecting big data. You're analyzing them. You're using machine learning. So, but you would like to make it privacy friendly. So it seemed to be a fascinating job and a very difficult one. So then I'm waiting for other questions, remarks. Many will. So
don't be shy. Just jump up and.
We go from.
So, thank you very much. It was really fascinating. And two questions, one political question, let's say, and the other one technical. In your privacy review of all apps, did it happen that, it make you think that your business model cannot stay the way it is in order to fit that? You see what I mean? So that your management, you're confronted with this kind of issues, and you're looking at that, assessing, monitoring whether this GDPR compliance exercise is confronting you with this issue. That's the political question. The second question is, in machine learning, I'm aware of researchers in order to at the same time understand whether it is possible to have the output together with a reasonable, simple, at the same time exhaustive explanations of the reasoning behind, which is one of, the machine learning output, which is one of the stakes for data protection, transparency, and explanation, and user awareness. And so, are you involved in that, in this kind of research as Google? So these are the questions.
Yes, thank you for both excellent questions. So I'll take first the logic of processing one first. Of course, GDPR requires an explanation of the logic of processing, certainly if it impacts fundamental rights of people. And I think the machine learning algorithms have to be explained. You simply have to explain what is the purpose of this tool. You can't explain the algorithmic complexity that takes place in the machine learning process inside, but I do think it's quite obvious that you have to explain what the system is designed to do. You could say, for example, I am using this system to decide whether or not to approve your credit card transaction that you just did. Because that's how credit card companies figure out whether to approve your transaction. I went to a Cyprus conference the other day, and my computer card company decided that my reservation of a hotel in Cyprus was simply too suspicious an activity for me to have done, and it refused it. It was a machine learning thing, no human being was sitting behind it. So yeah, on the logic, I think we have to explain the logic. There is a challenge about not being too complex in it. I think it has to be friendly to users. On the political thing, well, I remember, I've been in the field a long time, and I remember having very frank conversations. And frank is one of those euphemisms we use in the political world. Frank conversations about what did and didn't work in various proposals under the GDPR with many of the policymakers at the time. And people would sometimes go out externally and say, oh my God, these American companies are lobbying so aggressively. Well, we were certainly saying what we thought about what would and wouldn't work. But once it became the law, our job is to comply. And that's what we're doing. Now, large companies are investing a lot of money in this. Small companies, I have real doubts about what the average small and medium-sized enterprise in Europe is doing or frankly able to do, which is also a business opportunity for us. We're a business. One of the things that we can do is we can build cloud services, for example, that are built to comply with GDPR requirements. That's what we're doing. So that we can sell, that's what we're doing, cloud services to European SMBs, saying if you use our Google Cloud services, you will be in compliance, at least for that part of your business, with the GDPR requirements. If they don't get help from these large players, SMBs simply can't live up to their own obligations. So, I actually think that's a business opportunity. Some people could argue if you create a regulatory regime that is so expensive and complicated to comply with, you are favoring the large companies that have the resources to comply with them. That was a provocative sentence I just used, in case you didn't notice it. If you think the GDPR is problematic in terms of technology in the future, well, it's nothing compared to e-privacy. So we'll come to that conversation later today or tomorrow, but the e-privacy draft regulation, as I see it, is not future-proof. Indeed, I would say half of the future technology evolutions that we expect in Europe over the next 2 decades would be illegal under the current draft. I'll use one example. I'll be very blunt, but it's also very simple. Does anyone in this room think that self-driving vehicles are not going to be part of the European industrial future? Now, does anyone in this room who has read the e-privacy draft think that a self-driving vehicle could be made legal under that text? Well, the answer is clearly no. So if we have a text that is that misguided on something that simple for the future, I think it's back to the drawing board. So, people want to quote me on that one, feel free. Yeah.
Thank you for the statement. Next question.
Yes, since GDPR is every company has to meet that operating in Europe, what does the privacy shield bring? Is it just something to do with data transfers? Because Google is set up in Ireland, for instance. So why do you still do the data shield or the privacy shield?
Yeah, it's a good question. So if you go back to European data protection law, it was the case under the directive and will be under the GDPR. Transfers of personal data from Europe can only be made to a third country if that third country provides an adequate level of data protection. This is just in the law. The United States is not on the list of countries that provide so-called adequate data protection. Countries like Uruguay, Argentina, the Isle of Man, Guernsey, they are, but the United States and Japan are not. Okay. And so there has to be an instrument. You have to have a legal instrument for the transfers. The instruments can be privacy shield, they can be, this is simply to respond to a compliance obligation established by the framework of the law. That's all. That's the, and it, even if you comply with the GDPR, you still need to have a legal framework for compliance with an international data transfer to a country with so-called non-adequate data protection law. So these things will exist even if a company is complying with GDPR.
Thank you. Next question. Maybe in front, okay, and then we take the others.
Yes, thank you for your presentation. I'm Robert Madge from Zifrat Daten. So you mentioned the example of compliance with GDPR in data portability. And you said Gmail data going to a competitor, for example. To what extent is Google planning to go beyond the GDPR and allow users to extract or transfer to others data that's derived, for example, by machine learning?
We'll wait and see. I can't give you, in a public forum, I can't give you, here's a list of the data categories that will be subject to data portability. One of the questions, obviously, when you build a data portability system is, what data exactly are we talking about transferring? And there will be a gray area. There'll be a gray area between a user's data and the data that a company has developed that may have originated based on the other data, derived, as you say, quite correctly. So I just simply don't have an answer for you. Remember, all of this stuff is evolving over time, right? These are relatively new ideas. We've had an idea of takeout data now going back, I think, 5 or 6 years at Google, and it's iterating over time. You also have to ask yourself, who owns that data? Is it the users, or is it the company that has derived some value from it, collectively, statistically? Or in another way, I think you also have to ask yourself, what's useful to a user? Obviously, if a user wants to see their own emails, that is unambiguous. But if you're talking about server logs of interactions with other stuff, is it useful? Is also a fair question. Yeah. So, to be seen over time.
Good question for coffee breaks. So we have some questions in the back, and then we have one in the front. Okay.
Thank you. Stefan Schiffner from ENISA. First of all, thanks for this brilliant talk. because, and I say thank you first because I want to say something provocative.
I would be disappointed if you didn't.
Yes.
Yeah.
And now my question is basically, you presented your privacy settings, for example, the location service, which is from the usability point of view, brilliant, of course. I have a one switch, it says none of your business, great. What annoys me on this is when I say it's none of your business, I lose a lots of functionality. And well, though I'm basically trapped. And what I want to ask you is, why do you not use and implement more cryptography which can help to have both? To give me the option to say none of your business, and this might mean that I have to pay somehow for the service. I'm aware of this, you need a business model, no problem with this. I might find other ways to pay it, but I can use, for example, location-based service with talk to the people from Credential here, they're here around, for example, and other people. I can use the service, I get the same functionality, but you will not learn where I am and what I'm about to do.
Yeah, I am. Well, thank you. Good remark. Also provocative. Certainly food for thought. I would just simply add, one other dimension to the ways to think about this space. There can be the general information. There can be information about a person's specific location history. And then we can also have machine learning derived guesses about categories of people who might fit within a particular category and where they might be going. And I think there's a lot of future development possibilities in that space. So it doesn't mean I have to know where you precisely have been over time, but it might be able to say, there is a profile, to use the loaded term, of people of a certain category who have certain movements in common. And so some of those functionalities that you say rightly are lost can perhaps be restored, but not precisely tailored to the individual user, but to a category. We're already doing that. For example, if you see on our systems about traffic predictions, those are aggregated information based on statistical users that don't identify an individual, but will say the Ringstraße at this and this spot has a lot of traffic at this moment, but if you wait 30 minutes, statistics show it will go away, that sort of thing. Right?
Hi, I have two questions. One, it's related to privacy controls. So do you have any plans of providing privacy controls to anonymous users? So when I say anonymous users, I mean users who use Google products but do not have an account with Google. So it is still possible to track these users. So what sort of controls these users can get from Google, for example, like data deletion, data takeout? So that's the first question. And the second question is, what's the longest retention time that you set on users' data sets?
Okay. Both very good questions. So you're raising the question about how you provide privacy tools to the two different categories of users that we have at Google services. So one are the authenticated account holders. Like if you have Gmail, you must be authenticated account holder. That's the account settings that I showed you earlier. But there's this other very large category of people that do not use a Google account or that do some Google services without being logged into their accounts. We call them unauthenticated users. The kinds of privacy controls that you can build for these two communities of people are different. I mean, they simply are different. We can provide more privacy controls to logged in, authenticated users than non. That's just a fact. At the same time, that does not mean that we can't provide other privacy controls to the unauthenticated users. So you said, what kind do we do? Well, obviously cookie controls are lots of privacy controls that are used in the non-authenticated, non-logged in setting. If you look at our ads privacy settings, for example, those are privacy settings that an individual can do that are not logged in, non-authenticated, that's your question. A person can say, for example, non-logged in, non-authenticated, Google, do not show me ads that are targeted to my interests, what we call interest-based ad targeting. I don't want it, so don't show it to me. That's a kind of setting somebody can do today, already non-authenticated. Cookie controls are another. So what we can't do in the non-authenticated thing is take out, for example, I can't have someone come to a Google service that doesn't have a password, is not authenticated, and says, I'd like to download all of Peter Fleischer's emails. Or you just can't do that, right? That just can't build it that way. So these two will go in parallel. And it's always a good question to say, well, what are the controls that you can do on non-authenticated form? But they will never be as rich or as granular or as detailed as what we can do in the authenticated form. They just can't be. But good.
Okay, thank you. Now we have to move on. We have 3 questions, and then we collect them, and then maybe the last reply and some summary. Maybe here, and then here, and here. Yes, please. Right to you.
Jacques Rosebandau from NXP Semiconductors. I have a question related, or 2 questions related to IoT devices. We saw these privacy settings already, and you were looking into the connected devices, whether they are GDPR compliant or not. Are there any, so first of all, how do you deal with IoT devices when it comes to GDPR? You mentioned a lot of crypto functionalities, access control. Is there any IoT recommendation you give to developers who develop IoT devices, what they need to implement? And secondly, how do you deal as Google with your IoT devices?
Next question. Yeah. Next question, please. In the back. Yeah, the lady. Okay. Dan.
Hi, it's Bojana Bellamy from SIPL. So I like the discussion about governance and accountability, Peter, because I think that has to be the way forward. And to the point behind, I think it's completely okay to use data for commercial purposes as long as it is done responsibly and protecting data and ultimately privacy. And I think both are possible. So, question, give us some examples, please, to your future proofing of machine learning. So what sort of things could Google do as a responsible, digitally responsible company, accountable company, to deliver better privacy? Is it risk assessments? Is it better transparency? What are 2, 3 things perhaps that you're thinking of doing?
Thank you. Last question.
Wojtek Wiewiórowski, Assistant European Data Protection Supervisor. Well, the principles in the GDPR did not change too much in comparison with the directive. Being provocative, you said one moment that data minimization is the biggest crime against humanity that we do at the moment, because we will need this data in the future. Mm-hmm. So do you recognize it now like, well, okay, they are still wrong, but we have to comply with it? Or you change your mind as far as data minimization is concerned?
Thank you, Wojciech. I'm a man of faith, and my faith doesn't change. So we'll see whether I'm burned at the stake for it. Let me just, I think these 3 questions is always challenging to someone to get 3 completely different questions, but let me try to put them into one answer. The first thing I would say with Internet of Things devices is think about an Internet of Things device privacy scheme that works in the real world. Ask yourself how that scheme would work under the e-privacy draft. And let me be very precise. So we're talking about just things that are connected and communicate with each other. They're sharing data. Use my autonomous vehicle example. To have a world where you can have an autonomous vehicle driving down the street, the vehicle has to exchange data with hundreds or thousands of other things around it. It has to exchange data with every other vehicle on the street. It has to exchange data with traffic signals, garage doors, weather things, all kinds of location beacons that will tell it where it is, how fast it's moving, and more importantly, where other things are and where other things are moving. I mean, all these things must happen to enable the very simple thing of a car to drive itself down a street. Of course it does. So if you put one person shaking their head, we'll have a conversation later. But you know, the idea is, of course, it has to exchange data. Now, under the privacy regulation, we've essentially said the whole model of the GDPR is going to be disregarded. We're going to invent a new, completely inconsistent model. We just spent all these years coming up with the GDPR, and now we're throwing that out the window. And we'll say that basically consent is the model for exchanging data. Well, consent is a human concept, right? It's humans. I, a human, consent to the exchange of data. And another human says, I reciprocate that consent. But in this IoT world, there's no humans there in many cases. I mean, some cases there are, but in many cases there are not. And so the consent model doesn't work. So the GDPR would be fine because it has a legitimate interest model, which is one of the legal bases for processing data, and that model would work if it existed under the e-privacy regulation, but it doesn't. So we have an entirely different legal framework that doesn't work, where a bunch of things can only exchange data with each other, and not even just personal data, any data, if there's not consent, but there's no human being behind them, so there's no consent model that's possible. That just doesn't work. Now, in terms of Google, we can devise systems to be transparent in a number of different ways. So one of the challenges, for example, is to distinguish IoT devices that have a screen from those that do not. Well, if you're an IoT device that doesn't have a screen, it's an entirely different challenge about how to provide transparency and control, obviously. So it has to link to, let's say, a computer or a mobile device. It has to link to another device that will show people the data and give them those controls that otherwise the deviceless object won't have. Let's say my connected garage door, for example. And that's the kind of tools that we're building. When you look at accountability, accountability is the framework that, it's all of the stuff that a company does. It's all of the stuff that a company does to build a privacy framework that works and that respects these tools. The idea of having a steering committee at top levels of a company that reviews privacy guidelines, the idea of having a privacy review as part of the impact assessment, those are just elements of a much larger program that is the accountability program. And of course, we'll have to have an accountability program for IoT devices and for everything else. Which brings me to the idea of data and data minimization, Wojciech's point. I'm not getting into the slogans of privacy, and data minimization is one of those principles. The way I look at it is data has extraordinary value. Of course it does. Use my example of health. If I want to build a system to be good at spotting diseased retina, the more data that can be fed into the system, the better it will be. That's just obvious, isn't it? So if you asked me in that context, would I believe in data minimization, I would say no. Give as much data as you can to the system, it will be better. But you could say, does the system need to know the patient's name of the scan behind it? I would say, well, no, it doesn't. It simply has to know this was identified as a disease scan. So if that's the question of data minimization, then I would say, of course, that principle of data minimization is still being respected, because you build the system to get as much data as it needs and can use, but you design it not to use the categories of data that it does not need, such as the individual patient's name. So I think this principle of data minimization can survive. It's a question of using the right data sets that are needed but not using others. But at the same time, I'm a realist about the world of data. Data is an amazingly powerful tool. It's doubling worldwide in increments of less than 2 years, which means that in 10 years we're talking about data that is something like 40,000 times the data that we're dealing with today. I mean, this is logarithmic growth. It is astounding. I saw this poetic description, but I'll repeat it here because I kind of liked it. The number of bytes that we have on this little planet today is roughly the number of stars in the universe. So when you want to talk about data minimization, put it also into a context of reality. We are talking about very large systems, and that's a good thing, as long as it's designed with the core respect of the values that we care about. And healthcare, to me, is a great example where the more data you can get, the better you can build a tool to improve people's health. But everybody knows what the privacy principles are that need to be respected. I am absolutely delighted with the conversations here. I know our time in this session is over. I'll be back in a panel. I'll be with you all day. As I said, I see many friends in the audience. This is a conversation just today, but look, I've been in this field for 20 plus years. Many people in the room have been for many years. So I look forward to many, many more conversations like this in the future. Thank you.